All the presenters, everyone that attends this conference is so friendly, so willing to teach, so willing to learn from you too. So it's not just watching these videos, it's kind of getting that insight afterwards and around at dinner, at drinks, like all the other aspects of the conference besides just like that technical information.
Welcome to Getting Started with C++. This is the last session, I believe it's the last session in the Back to Basics track for this conference. We're going to talk about what the tools people need to get started with C++, how to get them on your system, and some sort of things to take away whenever you're getting started with C++. My name is Michael Price. I'm a senior product manager at Microsoft. If you feel that you want to get in touch with me later, feel free to pick up one of my business cards in the back of the room on the way out. And I have my email address on there. Also the email address for our team on there as well that you can email to the general Microsoft C++ team. There's a lot of content. I'm expecting it to take about 50 minutes, so hopefully we'll get through it and have time for questions. So some preliminary things. Welcome to CppCon. This is the last day of the conference in person, but we hope you enjoyed your time here. Please, go and take this survey down there at the bottom. We run this survey every year at Microsoft, and it helps us get an understanding of what people in the C++ community are doing. And it also, we may be contacting you to ask more questions to learn more about how you're using C++. You can also find us on the CppCon Discord in the Visual Studio channel. If you have trouble finding that, you have to go to the directory channel first, and then like one of the posts there, and it'll add it to your list. Okay. So this is a quote. I'm not going to read it. You can read it if you want. But this is one of the earliest Western classical descriptions of something called friction, right? It describes friction. It also kind of like hints at the idea that friction is different for a moving object versus a static object. And I've become sort of more fascinated with the idea of friction in the context of software products. So like, what is it that keeps users from finding and using and being successful in solving their problems with software? That's something called software product friction. And the highlighted, the italicized sentence at the beginning is important to me because it gives you an idea that, well, there are things you can change about the object to reduce friction. And that's one of the goals of this talk, is to reduce the friction for people getting started with C++. So I'm just going to do a quick survey. C++ has a reputation of being like a high friction language, right? So raise your hand if you agree that C++ is a high friction thing. It takes a lot of effort to get started. That's most everybody. Okay, keep your hands up. I'm going to have you lower them. As soon as you disagree with me, lower your hand. So would you believe me if I told you you can get a working C++ developer environment? Of course, we have C++ developers. On the most common operating system, that's Windows, with the most commonly used tools, without using your credit card or paying anything. Okay, hands are still up. In less than 15 minutes. Oh, we got a couple of believers here. That's great. We'll see if it's possible in the video that I'm going to show. Okay, so we're going to cover 5 topics. A lot of it is very front-loaded. First, we're going to talk about obtaining tools for your platform. We're going to talk about libraries. We're going to talk about security and safety, how to plan for the future, and then a collection of resources that you can go learn more about C++ on your own. So we'll talk about tools first. So editors, IDEs, compiler toolchains, and build project systems. First is editors and IDEs. So there's a lot of confusion in the community, just generally in the programming populace. What's an editor? What's an IDE? What's the difference? Aren't they the same? Why are they 2 different classifications? And the thing is that it's not actually a binary. It's a spectrum, right? So on the editor side, the editors are more focused on text editing, right? This means that you might, out of the box, get syntax highlighting for a programming language. But like, if it's a pure editor, that's pretty much what you're getting. A really fine-tuned and customized for text editing. But a lot of these editors are often extensible with other plugins and stuff. So those plugins might sort of add in information about the build system, or how to invoke compiler tools, or even running tests or using a debugger with that language. And as soon as you add those extensions into an editor, it starts to shift down the spectrum towards an IDE. So what is an IDE? An IDE is a bundled experience. Usually right out of the box, it's going to have all the tools you need to do the task that it's intended for, right? Usually really tightly integrated with the compiler toolchain and other tools. A lot of times they're focused on specific target environments. So like if you are doing work on an embedded chip, like you're targeting a particular microprocessor, sometimes the manufacturer of that microprocessor will have a specific IDE they intend you to use to target that chip, right? That would be an IDE. And usually they're extensible, but because so many things come out of the box, you usually don't have to install extensions in order for it to solve the problems that you're trying to solve. So what are some examples of editors and IDEs and where they fit on this spectrum? The first kind of grouping is I'm going to group as editors, right? So you've got Emacs, you've got Vim, or I've put NeoVim here in place of Vim, but consider them equivalent. Sublime Text and Visual Studio Code. These are really popular editors. And then you've got on the IDE side of things, this isn't proportional, but you've got Eclipse and Xcode and CLion and Visual Studio. How many people in the room have used more than 3 of these? About half or so, which is good. I'm guessing probably Android Studio and Emacs and Qt Creator are probably the ones people have used less in here. But we're going to talk about some of these in more detail next. So the ISO C++ Foundation does a survey every year, and they ask this question: which development environments, IDEs, or editors do you use for C++ development? The data I'm going to show is just for the primary. You can indicate primary, secondary sometimes, or these are just for the primary answer. I'm going to talk about 4 different IDEs. I'm going to talk about Visual Studio, Visual Studio Code, Vim, and CLion. Now, these percentages here are just from that data there. I would really recommend people go check out Anastasia's talk on doing surveys in the C++ community. She offers some really good input and sort of information on how surveys can be biased and stuff. And the information she presented, these 4 were also the top 4 in other surveys that they have, just in different proportions. But we're going to talk about these 4. So let's talk about Visual Studio first. Now, as a just sort of disclaimer, I work for Microsoft, so I'm trying not to be biased here, but Visual Studio is at the top of this list, so I'm going to cover it first. You can go to visualstudio.microsoft.com to check out Visual Studio, figure out what it is. It only runs on Windows, which is important to know. If you're on a Mac, you can't run Visual Studio natively on your system. But you can actually target Mac and Linux with its remote development capabilities. So you may run it on Windows, but you can actually build on these other systems. And the Windows subsystem for Linux is a great way to easily get Linux on your Windows system and have Visual Studio target it. So you can do cross-platform development all in one system. The licensing for Visual Studio is a little complicated. You can find out more information on the link there. But the important things you need to know, it has 3 different editions. It has the Community Edition, the Professional Edition, and Enterprise Edition. And the most important thing for this talk for beginners is the Community Edition is free in most cases. Okay? So if you are a student or I think maybe nonprofit or doing open source stuff, Community is free. If you're an organization that's producing a product that you're selling or putting out there, it's free if you don't qualify as an enterprise, which means you're a small organization, free up to 5 concurrent users, right? So if you've got a shop of 5 people, you can use Community for free. If you want to learn more about Visual Studio, I recommend checking out previous CppCon talks. We do one basically every year about what the new features are in Visual Studio, and you can find lots of great information about the details of the feature set there. So how do you go and install Visual Studio? Well, you can go to the link down there at the bottom, and it'll give you a download link to download the version that you want. Or if you've got a system with winget installed on it, which Windows 11 ships with winget, Windows 10 you have to install something to get it, you can run this one command line, and it will install Visual Studio 2022 Community Edition, and it will put the native desktop C++ tools, it'll install those as well, right? So like whenever I used to install Visual Studio, 15, 20 years ago, it was a, 5-hour process or something, and you had to keep coming back and clicking through the window, through the dialogues and stuff. It was a real pain. Now it's just one command, you run it, and you leave, you come back, you get a coffee or something, you come back and it's done. Okay, we're gonna move from Visual Studio to Visual Studio Code. We're gonna demo this later, by the way, a little bit. Visual Studio Code is an editor, but it's got a really rich ecosystem of extensions that make it so that you can use it for C++ development. Really great things about Visual Studio Code, it's free. Anybody can use it for free, even the C++ extensions. It runs basically on any operating system that you want it to run on. It'll even run like in any modern web browser, on your phone or on your iPad, your Surface, whatever you have. You can't do C++ development when it's purely running in the browser, right? Because you can't install extensions. You need more computation power than what the browser has you in its sandbox. But if you just have to go edit some files or something, you can just load it up in a browser and it works. You'll want to install the C and C++ tools extensions to get started easily with C++. And you'll see how to do that on the command line in the next slide. One thing to note about it is that since it's an editor, it's not an IDE, it doesn't come with any compilers or any of those tools built in, even when you install the extension. But we do have features that we're working on to make it easier for people to get the compilers for their target platform. Also, it's very similar to Visual Studio. We do a VS Code talk every year as well. Please go out and check these out. A lot of great information there. To install VS Code, if you're on Windows, you can use this winget command. It's actually two commands that semicolon just sticks the two commands next to each other. To install the CPP tools extension in one line from the command line, you can just run that code -- install extension. This actually installs the pack, which comes with like 3 or 4 different extensions that are really useful for C++ development. I think it includes the C++ tools, CMake tools, and Makefile tools, I think. If you're on Ubuntu, you can install it via the Snap Package Manager. And I think on Mac OS, you have to go download the installer and install it that way. Okay, Vim and NeoVim. Like I said earlier before the talk, I kind of learned programming inside Vim, so this holds a special place in my heart. I really enjoy seeing it in the top 4 of the popular editors. It basically runs on all OSs you could imagine. It has a really rich history going back probably 40 years. Similar to VS Code, it doesn't come with a compiler toolchain. You'll have to find those yourself. And it is also a free license. It's an open source software. There was a good talk last year on C++ coding with NeoVim. If you're interested in this, you can go check that out for more details. Also really easy to install on basically all the platforms. Winget also has a NeoVim package. Winget install neovim.neovim. Now you've got NeoVim on your system. You can use apt-get on Ubuntu, and you can use either Homebrew or Mac ports to install NeoVim on a Mac, on an Apple. Same difference, right? And then we've got CLion. So JetBrains is the manufacturer of CLion. If you're really curious about JetBrains, there's lots of JetBrains folks around the conference. If you haven't talked to them yet, you can go find them. JetBrains actually makes a lot of different IDEs that sort of target different languages, and CLion is their C and C++ one. But they have other ones as well if you're interested in. I think they have a Java one, they have a Python one, things like that. It also runs on the main popular operating systems. For Mac and Linux, it does not ship with a compiler toolchain, but on Windows, you can have it install a version of GCC that's called MinGW. It basically is a system that runs inside Windows that can run GCC. So it can actually get that for you on Windows. It is a pay-for product, and there is a free 30-day trial. I really do recommend going and talking to Anastasia or one of the other JetBrains folks if you want to learn more about that.
I think students can get it free.
Yes, it's also free for students in education. Great. Thank you. I talked to Anastasia actually earlier in the week, and I added some more information. If you want to go deeper for Sea Lion, you can go to their blog. They also have a YouTube channel. And then there was a talk at CppCon about Sea Lion a while ago, so it's a little bit older, but it's still useful. Installing Sea Lion is a little bit different. Their suggested way to do it is to use the JetBrains Toolbox app. You can download that on their website. But that lets you actually install lots of different JetBrains IDEs. You just kind of pick which ones you want, and it puts them on your system. If you want to just do Sea Lion and don't need to worry about the others, you can either use the downloaded installer from their website, or if you're on Ubuntu, you can install it via the Snap Package Manager as well. Okay, moving on from editors and IDEs to compiler toolchains. Everyone here in the room probably already knows what a compiler is, right? But we're going to go through this just so that it's a benefit. Maybe it's a compiler you were interested in using, but you haven't used. It'll show you how to get it. And for people online that are coming to this really fresh, it'll be good information for them. So a very brief description of how your source code goes from being a source in a text file to an executable. This is very high level. You've got a compiler and a linker, and you've got source files that go into the compiler. They come out as object files. The linker takes those object files and turns them into your application. Additionally, you've got a whole a big blob of thing called dependencies that you're going to be providing information about those things to the compiler and linker for them to work properly. We'll come back to this part in a little bit later. But this is the basic structure of how programs get made in C++. There's a lot more details you can go to, a couple talks from previous years that go into the details of what this is and how it works and everything. Okay, so moving on to the big three. People will often just say, oh, the big three, because they don't want to name them individually, right? But what we've got here is Visual C++, GCC, and Clang. So let's talk about Visual C++ first. So all of these compiler toolchains, when I say, I'm very specifically saying compiler toolchains, not just compiler, right? Because with a compiler comes a lot of other little applications that fit into its little ecosystem, right? So there's four main pieces of any compiler toolchain that most people will interact with, right? There's the compiler, which is cl.exe for Visual C++. Then you've got the librarian. This creates static libraries on your for that, of code that you're making. In Visual C++, that's lib.exe. You've got a linker, which is the thing I described before that takes all the object files and actually produces the binary that gets executed. For Visual C++, that's link.exe. And then you've got a debugger, right? The debugger that's used for Visual C++ most often is the Visual Studio debugger. This is like a top-of-class debugger. This consistently is like the shining part of the compiler toolchain on the Visual C++ side. There's a fifth component that isn't really a part of the compiler toolchain, but it often comes along with it and gets bundled, and sometimes they're kind of closely tied together, and that's the standard library implementation. So Microsoft has a standard library implementation called Microsoft STL. It's actually an open source tool. The rest of these are not open source, but the standard library is. And then whenever you install Visual C++, you'll get the Microsoft STL that comes with it. Okay, so how to get the Visual C++ tools. So when you install Visual Studio, you select different workloads that you want to pick, like, oh, I want to do Python development or C++ development or TypeScript development. If you pick any of these four workloads, you'll get the C++ tools. And if you're doing the command line that I showed you before, you can use those component IDs. And the example I showed was Microsoft.visualstudio.workload.native desktop. You can pick any of those to get different kind of combinations of additional tools to go with it. Like with game development, you'll end up getting like Unreal tools, like things that tie in with the Unreal Engine. Okay, moving to GCC. So GCC is actually an abbreviation of the GNU compiler collection. And it's got the same sort of components as all the others do, right? You've got GCC and G++ are the compilers. GCC is actually the C compiler front end, and G++ is the C++ compiler front end. AR is the sort of classic Unix librarian tool. It's short for archive. LD is the linker you would use, and GDB, the GNU debugger, is the debugger you use for GCC usually. There's also a standard library implementation that's tied in with the GNU ecosystem. That's libstud C++. That's how I pronounce it, libstandard C++ maybe, but I say stud. And there's lots of different ways to get GCC. So if you're lucky, they may have already produced binaries at that link at the top. But the recommended way for GCC is to actually build it from source. It's sort of like one of the big free open source software components. And so they really encourage people to build locally. If you use Git to clone that and then follow the instructions on those 2 links to configure and build, it'll get you going. Just be prepared to be waiting an hour or so while it does all its stuff, because it like compiles and then bootstraps and then compiles again and does all sorts of stuff. Or you can use package managers for different systems. This is usually how people will end up getting them because they don't want to build locally. Right. What this means, especially for the Linux, like each distro will pre-build and package their own version of GCC, and you could get it that way. Okay, Clang LLVM. So Clang LLVM is sort of like the newest of the big 3, right? It's probably 15 years old now, but before then it was basically Microsoft and GCC and maybe a couple other ones that aren't as popular now. Very similar, it's got the same sort of components, Clang and Clang++, just like the GCC and G++, right? C compiler and C++ compiler. You've got AR again. The linker is LLD, not LD, but LLD. And then, and I've got the wrong name here. The LLVM should be LLDB, LLDebugger. They've also got their own standard library implementation called libc++. And very similar to GCC, they've also got some pre-built binaries for popular platforms. You can also build it from source. There's the repo you need to clone, and then the instructions you need to build. What's interesting is that you see it says LLVM and not Clang, right? LLVM is actually a larger ecosystem, and there's lots of different languages that tie into it, and Clang is just the front end for C and C++. You can elect just to build that part of LLVM. The instructions will walk you through how to do that. And just like the others, you can use package managers for this as well. One quick note is that if you install Xcode, you will also get Clang, but you need to know that it's not the same Clang as Clang LLVM. So this is an open source project. Apple has their own fork of Clang that eventually they kind of pull stuff in from the main trunk of Clang, but like it may not be up to date with what the latest actual Clang is. So if you think something should be working and it's not, it's probably due to that difference. It trips up basically everyone. So, okay, moving on to build and project systems. Everybody remembers this graphic, right, from just a few slides ago? So this doesn't look too complicated, right? You got source files, you put them in a compiler, you get object files, you put them in a linker. You could probably type these out, right? Well, turns out that once you get anything beyond like a simple kind of toy program, it gets way more complicated because that big thing that says dependencies is hiding a lot of stuff, right? So like you're gonna have, if you're using modules, you're gonna have binary module interface directories with BMI objects in them, BMI files. If you have dependencies, you're gonna have header-only dependencies. They're gonna have directories with header files in them. If you have library dependency, you have all these things, and you have to be able to provide these just the right things to the compiler and the linker, right, to do this. And again, when your program gets more complex, it gets worse, right? You might have thousands of source files. You might have dozens of module interface files. You might have dozens of different kinds of libraries, right? This eventually sort of like builds up so quickly that you end up spending, if you tried to do all this by hand, you'd be spending all your time just like fixing the problems with your build scripts than actually writing code. So why do we need build and project systems? It's because they restore your view. Oh, I didn't even point out, there are all sorts of other things that I haven't shown in the diagram, right? It's even more complicated. So why do we need build and project systems? It's because they restore your view of your universe back to something more like this, back to something that's more simple, that you can actually reason about, right? And it'll take care of a lot of the nitty-gritty of getting your product built itself. So we're going to talk about three. These happen to be the three most popular ones based on, community feedback and surveys and stuff. Let's talk about MS Build. MS Build ships with Visual Studio, but it is not a Windows-only product. It actually runs on many different platforms. It's an open source tool as well. You can check out the repo right there. It runs on Linux. It runs, because you can run .NET stuff on Linux. I don't know, that's probably been possible for the past 10 years maybe. It natively supports C++ and C# and TypeScript and a lot of the other languages that are sort of in the Microsoft ecosystem. GNU Make. GNU Make is a part of the GNU ecosystem, just like GCC. It runs on multitudes of platforms, basically any platform you can imagine. It's also very, very much open source. It's language agnostic. You can actually write Java, build stuff in Make. You can do all sorts of other interesting stuff in Make. But if you do go down the path for Make and Make files, it is very white space sensitive. So like you use indentation to be semantic. And if you end up using spaces where it expects tabs, you'll get really obscure error messages that are hard to understand. So just be careful if you end up using Make, that you don't fall into those traps. It also, complicated projects, Make files can get pretty complicated. Some of the most complicated build systems I've been built on top, I've seen have been built on top of Make. And then we've got Ninja. Ninja is a relatively newcomer in build and project systems. I think it's about 10 years old and has only been really popular in the past 5 years or so. It's also an open source tool at ninjabuild.org. I think they've got downloads. You can download it there as well. But it also often comes along with other tools. So like if you install Visual Studio, the C++ tools, you'll get a version of Ninja along with that. Also language agnostic. One of the sort of novel pieces or things about Ninja is that it is really focused on one thing, which is making your builds as fast as possible, right? So it's not really that extensible, and they actually don't intend people to write Ninja build files themselves by hand. They actually intend it, and they say this on their website, that they intend it to be used with some generating tool that will generate the Ninja files for you, which is where we get into the next thing, CMake. So we had these three project and build system things, right? Some of them run, they all run on different, multiple operating systems. But MS Build's kind of like, it's kind of like a Windows thing, and GCC maybe, or GNU Make might be a Linux thing, right? What if I need to do multiple platforms, right? Well, I don't want to write both an MS Build script and a GNU Make script, and all those sorts of things. So CMake exists. It's a meta project system. You describe your project in a more abstract way. You feed it in there, and then it will generate the project files for whatever you pick. So let's see what that looks like. So you've got your CMake binary. This is an executable. And you feed into it a CMake lists.txt. This is basically the description of your project. And this happens in 2 steps. The first step is a configure step. You feed that into CMake, and it's going to generate output files based on what project system you wanted it to make, right? It can make Ninja, MS Build, Make. There's a whole bunch of them. It can make Xcode project files. It can do all sorts of stuff. Then the second step is you do a build. And when you do the build, you feed that output from CMake into the particular build tool, right? So like if you make MS Build files, it's actually Visual Studio generator files, but then you can actually load that up in Visual Studio directly like it was an MS Build solution file. Okay. This is a link that I found, there's probably lots of content you could go find about building project systems. I'm not going to say this is the best one to go look at, but it's at least something to hook onto. Usually there's not a lot of talks at conferences about the tool, those parts of the tools, because everybody's like, well, of course, everybody already is using these things. Why do we need to have talks about them, right? But hopefully that's enough information to get people started and clear up confusion about things. There's usually a lot of confusion around CMake. You're like, why do I have to configure and build? Why can't I just do build, right? Okay, so we're gonna do a little demonstration. It's actually not gonna be a demonstration, it's a video that I took. That way I don't have to pray to the demo gods that everything goes right. I'm gonna go ahead and get it started here. So 0 to debugging in 10, and it says 10. On some systems where I did it, it was 10 minutes. I should say 15 minutes, but because the demo is 15 minutes. Okay. So what I've got here is a recording of a blank virtual machine that I created. And I'm going to prove to you on here that, okay, oh, I got to click over here. There it is. Okay, so I have a little timer going up there, just so you know that I'm not playing tricks on you. I'm going to open up PowerShell, and I'm going to do a winget command. I'm going to tell it to list all the packages that are installed. Right, that's just to show you that, yeah, winget is working, right? Then I'm going to tell it to list anything that has visual in the name, just to prove that Visual Studio is not installed, right? Okay, Visual Studio is not installed. I'm going to use that command that I had in the slides to install this. And then when it's finished typing, it'll enter magic land, magic demo land, where time will move faster and we won't have to wait for 12 minutes to happen. Okay, so yeah, I'm still typing. So as I'm typing there, what I'll say is the speed of how long this is going to take is dominated by the size of your internet bandwidth, right? Because it's got to go download stuff, right? But that's by far the dominating part of the time, right? This used to not be the case. You get Visual Studio on a CD or DVD, right? So there was no download time, and it still took 5 hours to install. So we've entered into our time warp here, and it finished installing about 11 minutes in. So now I'm going to list again to see if Visual Studio is installed. Hey, look at that. It installed some Visual Studio stuff. Now I'm going to pause it real quick if I can. Go back. Can I go back? Oh, you can see it right here. Okay, so it's down at the bottom of the screen, but you can see some redistributables are there. Visual Studio Community 2022 is there. Microsoft Visual Studio Installer is there. So if later on you decide, you know what, I want to try some C# stuff or some Python stuff, or I picked the wrong C++ workload, I want to get a different one. You can actually now run the installer locally and select those new workloads that you want to install. It's a really nice feature. Okay, resume this. Okay, so I'm launching Visual Studio. First time you launch Visual Studio, it takes a few seconds, a dozen seconds or so to come up because it's got to, load a bunch of stuff up, right? And it's gonna walk you through the out-of-box experience, and it should come up here momentarily. Okay, there's an online, you can log in and save your preferences. I'm just gonna skip that for the demo. I'm going to pick a nice blue so it shows up on the presenter, the screen up here really well. I prefer dark mode, but it doesn't demo well. If you ever do demos, pick light colors, not dark colors, okay? All right, I'm going to create a new project. I'm going to pick a CMake project, and I'm just going to go with whatever the defaults are. I'm not even going to bother changing them for the demo. Okay, I'm going to move my window. Oh, I actually don't move the window yet. Close some pages that come up automatically. Now, at the bottom, it's kind of hard to see, but it's actually going to configure, it's going to run the configure step for CMake, right? So it's actually going and generating build project files in that step. Now I'm going to show you what it generated. Well, I'm going to show you why it generated what it generated. So this is a CMake presets file, and I'm going to highlight here that the build tool that it actually generated files for was Ninja, right? So if you make a traditional like Visual Studio solution file, that's an MS Build thing. right? But the default for new CMake projects is to generate Ninja because Ninja is fast, right? I'm gonna make some changes to my source file. I got rid of indel. If you haven't learned why indel is bad, you'll learn that later. Got rid of that. I'm gonna add some stuff, make sure I get my sentences correct with where my periods are. And then I'm gonna start the debugger. So I'm gonna do the build, start debugger, and set a breakpoint. So this thing will build. So now it's doing the build step of the CMake, right? It build, now the debugger's attached. And I can use those buttons at the top. There's also keyboard shortcuts to step through. You can actually change where the next line of execution is by just like dragging things or like setting it with a context right-click menu. And you can see I actually executed it twice because I ran it once, but then I drug that in where the next line to run was up, right? So you can really fiddle around with your product in the Visual Studio debugger. So I just demonstrated, I just used 4 of those 5 parts of the compiler toolchain. The one I didn't use was the librarian, but I used the compiler, I used the linker, I used the debugger, and I used the standard library. And then I also used CMake and Ninja and Visual Studio, right? So that demonstration, even though it may be under the covers, it used a large number of the tools that I just covered in the first section. Okay, we're gonna go on to the next slides because I'm running behind where I wanted to be. Okay, second section, libraries. So this is a quote from Bjarne from his Design and Evolution of C++ book called the D&E book from 1994. You can't just take 2 libraries and expect them to work together. Many do, but in general, quite a few concerns must be addressed for successful joint use. C and C++, particularly C++, is designed as a library language. It expects you to like be able to write libraries instead of like relying on things showing up in the language, right? And it has always been that way. And so we use libraries a lot. So I'm going to talk some about libraries, just a couple of points to keep in mind when you're thinking about what libraries you want to use. We're going to talk about how you manage libraries, and then how you might find useful libraries to use in your products. So about libraries. So some quick words. Why should you use them? Because usually domain experts wrote those libraries. If you're not an expert in collision detection, you should probably rely on the people who are experts in it to get it right. You can leverage prior effort, and it also isolates concerns, right? You don't have to worry about that implementation. Somebody else has done that. And as long as they've tested it, you're good. Things to think about, licensing. This is just a very simple warning. Do not use a library that is not clearly licensed, because you do not want to get in a state where somebody objects and says, no, you didn't have permission to use that code, right? You want a very clear license. Particularly some licenses will actually have a restriction that says if you use this, you have to make your code similarly licensed. It's called copyleft. Okay? You want to make sure that it's being tested, because ultimately, even though it's somebody else's library, you're using it in your product, so you should feel some responsibility to make sure the thing you're using is properly tested. And then you need to consider the integration cost. How difficult is it going to be to actually integrate this in with the other libraries I'm using and with the tools that I'm using? Okay. Managing libraries. So I'm going to show 2 package managers. We know from community surveys that most people are not actually using any package manager. They do things like put code directly in their source code, or just copy the source code and put it in a folder inside their project tree. At the same time, difficulty managing libraries is always one of the top 3 problems in the community. So you can imagine that these 2 things might be related, right? And if you actually dig into the data, people that use package managers have less issues managing libraries. Go figure, because that's what they're designed for, right? So I'm going to say you should pick up uses of a package manager early in your development practices, because it will save you all sorts of time and pain later. So Microsoft has one that they've produced called VC Package. It's a cross-platform package manager. You can actually get this on your system in lots of different ways. You can run this PowerShell command that will go and grab it. On Linux and Mac, you can basically source this file and use this wget to grab this shell script, and then source will run it, basically, and make it available on your command line. VC package is also bundled with Visual Studio C++ workloads. So if you install the C++ workloads, you've got a copy of VC package already. You just have to get it, you have to run it on the command line for now, but it's there already. And then you can also just clone the repo directly. It's an open source tool. And then there's a bootstrap command that you can run that will actually go fetch the binaries you need to use it. Okay, the second one, oh yeah, and if you want to learn more about VC package, we have really documentation that we're always improving on our Learn platform at that URL there. The second one I'm going to talk about is Conan. This is the other popular one in the community. This is made by JFrog, who also are the people that do Artifactory, which is another kind of common tool in software development. It's a Python app. It's written in Python 3. So to install to install Conan, first you have to install Python 3, and you have to install pip, which is the Python package manager. And then you just do pip install Conan. Okay? It's also an open source tool. I think you may be able to just do stuff directly from the GitHub repo as well instead of going through the other process, but I'm not as clear on that. Conan docs are up there, docs.conan.io, and then there was a talk last year at CppCon that talked about their new version that they released last year. And if you're interested more generally in how to manage C++ dependencies, our product manager behind VC Package gave a talk last year just generally speaking about dependencies and how you can manage them. You can go view that talk there. Finding libraries. If you're using a package manager, finding libraries is actually really easy. If you're not, it's harder. So VC package, you can just run VC package search, provide a query string. It'll search the name and the description of the packages and come up with a list of things that might be useful for you. You can also go find the catalog out at vcpackage.io/en/packages. Similarly for Conan, they offer a search as well. I believe that it takes a direct reference to the package name. I don't think it does a general search of any descriptions or anything. So you have to already know the package name or may be a good guesser to get it right. You can also look at their catalog of packages at conan.io/center. And if you are just maybe you don't want to use it, you just want to see what libraries exist. CPP Reference maintains a list of libraries on their website. It's a very exhaustive, extensive list. But it is manually updated, so it may be out of date, but it's useful. Okay, that's finding libraries. We've got 17 minutes. I think we can get through it. So talking about, okay, we need to be concerned with making our software secure. C and C++ have a reputation for being unsafe languages, and on a technical language perspective, yes, they have certain unsafe behaviors like memory safety issues. So this was a quote from a document produced by the US government National Institute for Standards and Technology that's just describing generally, not just for C and C++, what developers need to do to make their software secure. Really, really good read. I recommend people go read it. It is a government technical document, but it is still really, really useful. We at Microsoft have put out something on our Learn platform that actually describes how you apply what they describe in those guidelines with the Microsoft tools. Also a really good read. It kind of gets down to the nuts and bolts of how you meet their guidelines. Okay, we're going to talk about two different things, finding bugs and unit testing. Very briefly, unit testing. So how do you find bugs in your software? Because if you write software, I'm sorry to tell you, you write bugs, right? It's unavoidable. You have to employ other means by which to detect those bugs. And this doesn't matter which language you're writing. People write bugs in Rust too. Okay, well, we've seen this before, right? So one of the easiest, simplest ways is to adjust what warnings your compiler gives you. Most compilers have the ability to sort of tweak the set of warnings that it will issue. And usually these are really good indicators that you have a bug if you have a warning. Don't look at it and go like, oh, it's a warning, I'll ignore it. Right? A warning means there's probably the compiler's yelling at you, hey, I'm not going to stop you, but there's a problem here, right? You can turn warnings into errors. You can force that if you want with different commands. Visual C++ also has the /analyze commands, switches that you can provide to the compiler. Technically, those are static analysis that I'm going to cover next, but it behaves differently than a lot of other static analysis tools. So I'm including it here. So you can actually stop your compiler from generating code if you treat things as warnings. We recommend that. And it forces you to fix those errors. Static analysis operates usually differently. Usually with static analysis, you actually feed your source code into a different tool, which then produces a list of potential problems, right? Then it's up to you or your organization to decide how are we going to remediate these problems that it found. And it can generate lots and lots of them. If you're interested more in static analysis, there are lots of static analysis tools that you can pick from. Just as another sort of disclosure here, I currently work for Microsoft, and I used to work for Synopsys. So I've worked on at least 2 of these static analyzers before. So please use them. OK, then there's something called dynamic analysis. Dynamic analysis is different. Instead of feeding it to a different program, what you're doing is you're providing your compiler and linker special switches that are going to produce a special version of your application called an instrumented binary. Okay? There's going to be additional sort of like bits put in your application so that when you run it, it can detect that something has gone wrong and then either fault or give you, a report of failures, right? And when you do dynamic analysis, there's lots of different kinds of dynamic analysis. The popular ones these days are what's called sanitizers. Address sanitizer, leak sanitizer, thread sanitizer, undefined behavior sanitizer. These are just 4 of the really popular ones. There's like 20 or 30 of them that Google has made. These are all introduced by Google. They're available in GCC and Clang. Visual C++ currently only supports ASAN, address sanitizer, but it also has a mode of address sanitizer that won't kill your program the first error that it sees, which is the default behavior. So you can run it in a CI system and get a bunch of errors all at once. OK, so which approach is best? Static analysis versus dynamic analysis. Let's look at them. Static analysis finds likely problems. Dynamic analysis finds definite problems. Like, these are things that definitely happened, right? Static analysis, you run it one time through the tool, and it's going to produce a report with 1,000 potential defects if it's a mature code base that hasn't been triaged before. With dynamic analysis, you run it, it may like cause a fault, which issues a report. Then you run it again with different command, like different inputs or different conditions. Maybe you run it for a long time, right? That's the next one. Static analysis is really computationally expensive. The tool has to do a lot of thinking about your code in order to reason about it without executing it. But dynamic analysis, you can run it for as long as you want. Usually you run it with like your unit tests, right? But you may actually run your actual product, and you may run your tool for a week to see what happens, right? And then static analysis doesn't affect the actual binary product that you're making, but dynamic analysis definitely does, and you definitely should not ship that instrumented binary outside of your org, because that in itself is actually a security vulnerability. So please, please, please do not ship instrumented binaries to your customers. So which approach is best? Well, it turns out both of them. You should use both. They're both the best, right? They both solve slightly different problems. Sometimes they overlap, they'll find similar problems, but use both of them. They're both tools that we need to use for C and C++ to make them secure. Okay, real briefly on unit testing. I'm not going to go into the details of unit testing or philosophy of unit testing. I'm just going to show you some frameworks and libraries that you can use and how to get started with them. So I'm just going to list 4 popular frameworks. Google Test. If you're using a package manager, you install gtest. That's the name that you want. The Microsoft unit testing framework ships with Visual Studio. It's not available. It's not with a package manager. It just comes with Visual Studio. If you're only doing like Windows stuff, like this is perfectly fine. You don't have to have an external tool, right? It hooks into Visual Studio really well. But if you're doing multi-platform, you can't use it. You need to use one of the other ones. Catch 2 is another really great one. Again, you can just say catch 2 in your package manager, and all of a sudden you have it. And then Boost Test is another popular one. It's used to test all of the Boost libraries that exist. This is the one that it's different package names for VC package and Conan, so you have to pick the right one. But the other ones, they have the same name. Okay, earlier in the conference, there was a Back to Basics on testing. I recommend you go see that by Phil Nash. That'll help clear up some unit testing questions that you might still have. Planning for the future. So I really love this quote. This is from Titus Winters and some other co-authors that he had. And he gave this, he actually presented a talk on this at CppCon, one of the plenaries, I think, in 2019. And he had this line. Within Google, we sometimes say software engineering is programming integrated over time. I absolutely agree. There's more to software engineering than just writing like typing software, right? You have to plan ahead to really do software engineering. So I'm going to talk about two different kinds of tools that you should consider early on in your experience, learning these tools and becoming proficient in them. They have nothing to do with C++, but they will make your life so much better. That's source control and continuous integration. So first, we're going to talk about source control. Git is by far the leading source control system that exists these days. There used to be lots of others that were common, but Git has sort of taken a very dominant position in the source control market. You will improve your life as a developer if you go learn Git. Unfortunately, it is a non-obvious tool. It can be difficult to penetrate, but you can learn the basics of it fairly quickly. Just be prepared for some arcane, weird stuff. In addition to just using source control, you really should be hosting your source control somewhere that's not your laptop or your desktop machine. Because if that thing melts, you've now lost all your stuff if you haven't backed it up somewhere. If you're using a hosted source control provider, it's backed up already, right? These are 4 really popular ones. 2 of these are actually owned by Microsoft, GitHub and Azure DevOps. GitHub is by far the most popular out in the ecosystem, but you also have alternatives like Bitbucket and GitLab. And then to go along with that, you should really be considering continuous integration. So that is, whenever you push code up, the continuous integration will go build your code on all the platforms that you're trying to target, which maybe you only built on one platform locally before you pushed it. And it will tell you all the problems you have. It's really useful if you then hook in all those other tools like dynamic analysis, static analysis. If you hook those into your CI, you're going to produce a better product that way. Okay? This also helps, like, if you've made a mistake somewhere, tracking down where that mistake happened. Using source control and continuous integration really, really does help with that. It can save you literally weeks of time, like trying to figure out what went wrong and when it went wrong. I gave a talk last year on some of these topics at CppCon. GitHub features every C++ developer should know. You should go check that out. Okay, last section. Some resources for learning modern C++. So the landscape is different than what it was 15 years ago. At one point in time, there were some C++, a small amount of conferences you could go to that had C++ content. And then in the late 2000s, they kind of like disappeared, right? And there was really one that kind of stuck around, that was BoostCon. It came back as C++ Now, it got renamed and kind of reset. But really all of these conferences started getting created around the time C++ 11 shipped. So that change in the language really rejuvenated a lot of the conference talk area for C++. So, you know, I encourage you to, you're already at CppCon, right? Most of these conferences, you know, post their stuff online. You can go view those on probably YouTube. But attend these conferences. This is, you know, like I'm talking to the crowd here, you know, like people already at CppCon. But if you're online watching this later, really consider going to these conferences in person. They really are worth it. And they're all over the world these days. A couple of at least one of them, Pure Virtual C++, is one that Microsoft runs. It's an online-only talk that's just one, like a half day, basically. So very low commitment. There are also C++ user groups all around the world. Every country, every nation here that's shaded in blue is one that has at least one user group according to the ISO CPP org website. This is a manually managed list as well. So again, it may be outdated, but there's a good chance that wherever you are, unless it's somewhere in Africa or Saudi Arabia, I guess, that there's a conference or there's a meetup somewhere near you, right? Go find them. Go to this link that is organized by country. So it's really helpful. And then lastly, a few sort of learning resources. This is non-comprehensive. These are just some of the ones that I think could be useful for beginners. CPP reference, invaluable. Do not try to go read the standard itself. You will get confused and frustrated. This is like a distillation for humans of what the standard says. CPP Insights is a tool that you can punch in code and then it will like show you what that code is really doing. It's like there's a thing called syntactic sugar and it will kind of like erase the syntactic sugar and show you what a range for loop does, for instance. And related to that, there's Compiler Explorer, probably the most well-known tool in the C++ community. It does a lot of great things. It will show you the actual assembly code that gets generated. You can actually compare different compilers and see, oh, does this compiler support this? Or, oh, this thing generates binary code that's different than this one. And you can sort of explore the lower level details of C++ that way. And then I'm going to pitch two Microsoft resources. We have really great C++ documentation on our Learn platform, which is the Microsoft documentation system. It walks you through how to write software that targets Windows and that is on our products like Visual Studio and Visual Studio Code. Really, really great resource. And then lastly, a pitch for my own team at Microsoft. We produce a blog where we talk about our products, but we also do general C++ posts every once in a while as well. We have several people on our team that contribute to the standard and that have proposals that you can go find out more information about our team and the stuff we're working on there. And that's, we're at the end of the talk. I just wanted to leave you with, the mission of the Microsoft C++ team is to empower every C++ and their C++ developer and their team to achieve more. And we really do mean this, right? Like, we want to make our tools make it your job easier, right? And so this is why it's important to us that you go look at our talks that we've had this conference, but also fill out our survey, right? This helps us fulfill our mission that I just described there. And with that, we've got about 3 minutes for questions if people have any questions. We can go back to that slide. So.